Hello, welcome back. This is lesson number 6. I call it Chamfer. I have partnered with Dream Technology System to produce this video. I hope that everybody learned something from it. The standard content is going to be the file open. We introduce you a new tooling as well as the step-by-step how to accomplish it. The standard ZW3D interface, upon you open the application, we need to open the file that we have on the last training. The file that we select, and then we click open to open the file, choosing the cam plan to see how is the toolpath that we make on the last round. You can see that the raw material and the top facing roughing has been displayed. We need to hide this one, but before we do that, we need to introduce you a chamfering tool. A chamfering tool is a 45-degree insert type of tool. Main purpose is to cut the four corner to remove the sharp edges so that our hand can grab on the part. This is the safety move on the part design by the engineer. How we going to go about to do that? First thing, we need to hide the raw material as well as the top facing that we did on the last round. This is a result upon hiding both of them. We click the 2-axis mill and select the chamfer. We need to create a profile for it, so this is how we're going to go about. We create, and the chamfer is being pre-selected. We just need to click OK. We select the edges 1, 2, 3, 4. So you need to flip the part along the way by using the right mouse. Upon completed selecting the four corner, use the middle mouse, the roller, you click, and we need to choose the right and outside on the machining side to make sure that this is correct, because we need to chamfer the outside of the part. We click OK to accomplish this step. The tool will disappear so that you can put in the name by D25, because we're going to use a diameter 25. Chamfer tool, change the diameter to 25 and put the tool number 3 for this round, because this is the third tool that we're going to use for this part. Click OK. We're not going to calculate it for now because there is also parameter need to update, so we say no. First thing need to change is going to be the frame, so we need to change to G54, and that is going to be the result after you change. The tool details, which is the speed and fit, we have decided to put 500 and 100. The next thing to change is going to be the engage as well as the slot cut. We're going to put 100% because it's one cut only, so no need to do so many steps on it. So we need to do 100% as the cutting speed that we choose. We click OK for it. The next thing is going to be the tip depth. We put -1. I'm going to explain this one detail in the later time to make sure that the two edges is not at the corner of the part edge. This is to prevent that. Most of the time we're going to do -1. We put 2 mm and 2 mm for the engage and the the retract, not extract, to clear away the toolpath, the parts during the toolpath on the engagement as well as the retract. Upon that, we do calculate, and this is the result after you do the calculate. We click OK to accomplish it, and the next step we need to do is to verify the toolpath whether it's okay. Need to change the G54 for the frame to ensure that the tool going to the correct depth. Use the step-by-step to see. You can see that ultimately the tool stop at Z-3, which is correct, and you can see that the tool actually at this lower corner, they are actually deeper than 1 mm from the one that we put in the parameter -1. This is how appeared to be. We click OK upon we decided everything seems okay. We go for the solid vertical cut, choose the speed as well as the play button to see the toolpath that generated by these 3 operations. Upon that, we need to add the operation for the NC output. We right click and using the add operation, select the chamfering and click OK. the chamfering portion is being added, and the next step is gonna be output NC. Upon click that, you can verify the two path, the G code, whether it's okay. Seems like everything's to be our expectation. We change only one cutting speed at 100, no cutting speed, the feed rate 100. Everything seems running well. We finish our chamfer on the parts. We need to save the file, ensure everything is okay. So we finish the theory portion for this round. I'm going to move to the practical step by step to show you how we're going to accomplish this task. Hello, welcome back. I'm going to show you the step by step how to do the chamfering on this part. We're going to open the file. We select the cam plan, type the raw material first, as well as the top facing. The next thing we need to do is that select the 2-axis mill, chamfer. We need to create a profile for it. So we click OK for the chamfer. Select this corner, second corner, using the right mouse to click to rotate, and then we click the left mouse, having fourth corner selected, using the middle mouse to click. And the next step need to do is to use the right and outside. We choose OK to complete the profile. The next thing need to do is that we need to put the diameter 25, chamfer to, change the diameter of the 225, put 3 for the 2 number. We click OK. We have complete the tooling. Now the next thing is to need to change the detail of the parameter. First thing need to change is the frame. We need to change to G54. The cutting speed is 500. The RPM is 500. The feed rate is 100. We need to change the engage as well to 100%, as well as the slot cut. Click OK. The next thing we need to do is that we need to change this 2 path setting by showing -1. Actually, you can see the detail. The tool will go deeper to prevent the edge build up on between the tool as well as the workpiece if we are not going for deeper dimension. The next thing we need to update is the engage 2 mm as well as the retract 2 mm. The next thing to do is to calculate whether is everything okay. Seems like it's good. We click OK. Verify it if everything has according to our plan. First thing need to change on the verification is to set to G54. We can rotate the part to the way that we want it to be. 1, 2, 3. You can see that Z is at -3. Ensure that everything is correct. So we need to make sure we can flip this part to see whether everything's okay. We can move the one and roll it up. See everything seems good. The next step is going to show you the next corner go in, and then the next corner is going to be like that. And we can flip the parts at the next 1, 2, 3, 4. Seems like for all 4 corners is okay. We click the tick to finish off the verification. We can do the solid verify by clicking the right mouse, solid verify, choosing the speed to 0.8. If you want, you can play it. This is the rough facing, the second path, and the finish facing, and the 4 chamfering that we do. Seems good. We close this file. We need to add the chamfering operation inside, so that make sure that we output it correctly. Add operation by right-click mouse, chamfer, cut, OK. Output the NC file. We want to verify the chamfer, the G code is correct. Seems like the depth is going to Z3, as well as the 4 corner that being cut. We have finished the step by step how to do this chamfer. We need to save this file for the future use. But actually we have completed the whole component. save it for verification and the future in the future time. So thank you for watching. I will introduce more and the detail of the balance of the two path. Thank you for watching. See you next time. Bye bye.